I'm headed to the UK, and I need a VPN so I can access my home network and NAS on the go. VPN stands for Virtual Private Network, and VPNs are used for a lot of different reasons. Companies have VPNs that let employees work from home but using office systems. VPNs also encrypt traffic to protect your data when you're on public Wi-Fi. And some VPNs allow you to choose a region to access content that might be region locked. But for me today, I can't rely on that. I need my own VPN. This video is going to show you how to build your own private VPN for your home. It doesn't take much. I built mine using the Raspberry Pi, and the only other thing you need is an internet connection. And you don't even need a Raspberry Pi. You can run a VPN on a used mini PC like this one that I bought used for $100. This thing would run the VPN even faster than the Pi. Of course, speed also depends a lot on your internet. I have Spectrum Gigabit, but that gigabit only refers to download speed. Upload speed, which matters a lot more here, is stuck at 35 megabits. But I can live with that. I just have to
stop all the downloading!
At least when I'm on my VPN. But you also need a public IP address. It doesn't have to be static, meaning it stays the same forever, but it does have to be public. If you have 4G or 5G internet, your ISP might be using something called CG-NAT. If they do, you can't run a private VPN, but there are options. I'll get to those later. But how do you know if you have a public IP address? Well, visit icanhasip.com and copy out the IP address it gives you. Then open Terminal or PowerShell and run traceroute, then your IP address. Oh, and on Windows, traceroute is actually spelled traceRT for some reason. If it just shows one line like this, then you're good to go. If it shows more than one line, then you're stuck behind CG-NAT. Now, I do have an IP address, and I have this little Raspberry Pi. By the end of this video, I'll be able to access my home network the whole time I'm in the UK. And best of all, I won't use any cloud services to do it. And that awkwardly leads me to this video's sponsor, Surfshark. It's ironic because this whole video is about making your own VPN, right? Why would Surfshark, a cloud VPN provider, sponsor this? Well, I still use Surfshark in addition to my home VPN because sometimes I need a different kind of VPN. Sometimes I just want an encrypted connection for when I'm on public Wi-Fi, or I want to be able to watch one of my favorite shows that are region locked in the US while I'm over in the UK. Surfshark solves both problems, and they have a way faster internet connection than I do. They also have tons of servers around the world, and even some cool features like static IP addresses, and even an add-on called Dedicated IP that makes it easier to use Surfshark even through other secure VPNs. VPNception? I love it. And to top it all off, guess what protocol they use by default? WireGuard, just like we're going to set up in a few minutes. Sign up using my link below, or just use the code RedShirtJeff, and you can get an extra 3 months free. Plus, they have a 30-day money-back guarantee, so there's nothing to lose if you try it out. So, what's the quickest way to build your own secure private VPN at home? PiVPN. On the website, it says it's the simplest and fastest way to install and set up an extremely secure OpenVPN or WireGuard server on your Raspberry Pi. And you don't have to have a Pi. You can even install it on a VPS or most any computer running Debian. So let's get started. I already flashed Raspberry Pi OS to this microSD card with Raspberry Pi's imager. And when I did that, I also set the hostname to pivpn.local and set up a Pi user and password. I also recommend using an SSH key, but you don't have to. So I put the card in my Pi and plugged it into my network. After it booted up, I connected with SSH. You could also do the setup with a keyboard and mouse, but I don't even have my Pi plugged into a monitor, so that wouldn't be very easy here. Your PiVPN computer should have a static IP address on your home network too. And you can do that on your home router, or you can set an IP address during the PiVPN setup process. I did it on my router because that's how I manage my other home lab servers. And this is entirely optional, but since I bought a domain name that I use for all my home lab servers, I actually changed the local host name for my PiVPN to pivpn.gearly.net. So now that I have a persistent internal IP address and a host name, I can log into the Pi and run the PiVPN installer. I just ran the script from their website and followed the guided installer. When I was prompted to pick a VPN option, I chose WireGuard since it's a lot newer than OpenVPN and slightly faster on my Pi. I kept the default port, and since I run Pi-hole on my network and use it for my home DNS, I chose the custom option for DNS provider, and I input the IP address of the server running Pi-hole. If you don't run Pi-hole, you could use something like Cloudflare DNS instead. For the DNS or IP option, I chose to assign a public DNS name to my VPN server for one of the domains I own. Now, I won't tell you exactly what that domain is because last time I did that, some idiot started DDoSing my home internet until my ISP threatened to cut me off. I made a whole video about that. So yeah, not gonna do that again. But to make that custom domain work, I added a DNS-A record for my home's public IP address to my domain settings. I usually grab my home IP address by running curl icanhasip.com. You could also visit that domain in your browser. To make sure the traffic gets through to PiVPN, you have to enable port forwarding on your router. On mine, this is what that looks like, and I set up the external UDP port 51820 to point to the internal static IP address I set up for my PiVPN. Now traffic from the public internet can route through the Pi to PiVPN. Now, at this point, if all this talk about UDP, routers, and static IPs has your head spinning, I have to give a bit of a warning. Security is a huge concern here. Don't set up a VPN if you don't know what you're doing first. If someone gets access through the VPN to your home network, they could hack into anything in your house. Along that theme, another way people can break in is if you don't have your software up to date. PiVPN helpfully offers to set up automated updates on your computer, but I recommend even more security hardening, especially since this computer's exposed to the internet. For me, that means running my Ansible security playbook. I have a whole video in my Ansible 101 series where I talk about the first 5, the first steps you should take securing any Linux server. Go check it out by clicking the link right up there. After PiVPN finishes setting things up, it recommends rebooting, so go ahead and do that now. Now you have a running VPN, but no way to connect to it. You need to create a new client profile for each device you want to connect. Log back into the PiVPN computer and run the command pivpn add. It'll ask you for a name, and for me, I usually set a name like username, device type, and network identifier. So in this case, jgeerling-macbook-home. Doing that lets me remember exactly what client I'm looking at. After it generates the config file, you need to copy it to your computer. I usually use SCP or secure copy like this, but you could also use FFTP or just cat out the file and then copy the contents into a file on your computer. Now, I have a Mac, but the process is pretty much the same on anything. I installed WireGuard from the Mac App Store and opened it. Inside, click Import Tunnel from File and choose the config file you just copied over. Now comes the moment of truth. To make sure the VPN actually works, you should test it on an external network. You could tether your mobile phone, but since I was with my dad filming a Geerling engineering video today, I hopped on his Wi-Fi. I went into the terminal to check if I can ping one of the computers on my home network. And I can't, of course, because I'm on his network. If I turn on the VPN connection, though, I should be back on my home network, but this time from the radio station. And if I ping that computer again, there it is. Now I have my own completely private VPN. The next thing I wanted to do was see how fast it was. There are limitations here, from my dad's Wi-Fi speed to Spectrum's slow upload speeds, but it's helpful to know. So while I was connected, I ran some speed tests and I got speeds anywhere from 5 to 20 megabits. Then when I came home, I ran a speed test and got over 500 megabits just on the home connection. So to test the theoretical limits, I connected through the VPN while I was on my home connection and got speeds from 30 to 200 megabits. So my slow upload bandwidth really slows things down. Plus there's a little overhead from the tiny Raspberry Pi encrypting the connection, but it works for what I need. The other main thing I want to do is use Home Assistant on my phone without relying on any cloud services. So to do that, the first step is installing WireGuard on my phone. There are apps for Android and iOS, and after I install it, I can add a new connection using a QR code. To generate one of those, let's head back over to PiVPN. First, create another client for your phone. I called mine jgeerling-iphone-home. Then run PiVPN-QR to display a QR code right in the terminal. Point your phone's camera at the terminal window, and there it is. Just name it the same as you typed in PiVPN, and then go ahead and test the connection. Disconnect from your home Wi-Fi if you're connected, then activate the WireGuard connection. Visit icanhasip.com in your browser, and it should show your home's IP address. This is great. Now I can make sure Red Shirt Jeff's not in the workshop starting a fire or blowing anything up. Now, VPNs aren't always simple. If you have any issues, the first thing to do is run PiVPN-D. This runs some self-tests and displays a ton of debug information. If everything checks out okay, it could be you have DNS issues. It's almost always DNS, and that's why I have a shirt for that over on redshirtjeff.com. Another handy command is PiVPN-C. That shows a list of all clients and their last connection times with data transfer stats. And it's a good idea to back up your VPN configuration in case your little VPN computer ever dies. Run PiVPN backup to generate a backup tarball inside the home directory, then copy that off to a safe place. Restoring is as simple as copying all the files from that tarball back to a fresh install of PiVPN. You might be wondering what to do if your home doesn't have a static IP address. Well, me too. I mean, I have a pretty stable IP address, but it does change every few months. If your public IP address changes, you have to make sure the DNS-A record you set up for your VPN is also updated in your domain registrar account, and that's not always easy to automate. The best way to deal with dynamic DNS or DDNS is to use a service like DynDNS or NoIP. But to do that, you have to run something on your router or a computer on your home network that periodically updates their server with your home IP. In my case, since I'm a little overcautious, I publish my IP address to a private VPS I run on DigitalOcean. Then, if my VPN connection fails, I just log into that server and grab the updated IP address, then I put it in my domain settings. I have a custom shell script that looks a little like what you see on the screen, and I have it run on a cron job on my PiVPN. I could probably make it better though. I could make it so it detects when the IP address changes, and if it does, I could have it send me a Slack, a Telegram, a WhatsApp, a Signal, an email, a Discord, a Skype, or whatever chat app is in style these days. But I'm a simple man, so I don't. Now, at this point, you might have what you need and be on your merry way. But there are two different use cases PiVPN can't cover. First, what do you do if you're stuck behind CG-NAT, like I mentioned at the beginning of this video, and PiVPN doesn't work? And second, what if you don't need access to your home network, but you just want some of the protections a VPN has to offer, like encrypting traffic on public Wi-Fi or bypassing geographical content restrictions? First, I'll cover CG-NAT. Unfortunately, if you have CG-NAT, you can't really run a private self-hosted VPN since you don't have a direct gateway to the public internet. You could call your ISP and see if there's any way to get a public IP address, but don't get your hopes up. Sometimes it's impossible, like with Starlink, and other times you have to upgrade to a business plan, which could cost a lot of money. Otherwise, you could use a service like Tailscale, Cloudflare Tunnel, or TwinGate. It does mean you're dependent on a cloud service to access your home network, but I've used all three, and I think they're pretty good. But maybe you don't need a private home VPN at all. If you just want a little extra security on public Wi-Fi, or if you just want to bypass content restrictions, there are a bunch of decent and affordable VPN providers. And the one I use? Surfshark. And not just because they're sponsoring this video. I've been using them for a while now, and if you want to try them out, make sure you use the link in the description. Until next time, I'm Jeff Geerling.